Hello and welcome to the Actuarial Raster channel, the channel where we break down actuarial exam questions step by step so you can answer them accurately and on time. In this series of videos, we'll be going through the Black-Scholes formula. The first thing that the examiner is fond of testing is the assumptions. They are very easy and these are very easy marks to score. So the first assumption is the price of the underlying asset follows a GBM, a geometric Brownian motion. There are usually no arbitrage opportunities here. The risk-free rate of interest is constant. There are no taxations and no transaction costs. Unlimited short selling is allowed, and the underlying assets are traded continuously and in infinitely small amounts. From there, we'll go to look at the Black-Scholes formula. In another video, we will look at the PDE approach. So in this series, in this video first, we'll be looking at the Black-Scholes formula. So the Black-Scholes formula, they are two, one for the call option and another for the put option. Before you even try to figure out the formula, first you have to remember the payoffs for the call option and the put option. For the call option, this was the maximum of ST minus K and 0. So the value of the call option using the Black-Scholes formula kind of follows that same principle, where it is ST less K. But now we add other factors here. So on ST we add the phi of D1, and then on K we bring it to the present value and then add the phi of D2. Uh, Before even that, I should have mentioned that ST is the share price at time T, K is the strike price, and then R is the risk-free interest rate, and capital T less T now is the time frame. The values of D1 and D2 are given here. So I'll skip this first. So the value of D1 is given by the log of the share price at time T divided by the strike price plus into a larger bracket the risk-free interest rate of interest plus half of sigma squared. This is volatility, and then into brackets the time frame, and then sigma square root of the time frame, and then D2 is given by D1 less sigma square root of time frame. You have to cram these formulas before the exam, since even though you can find a version of this formula in the tables, I would advise that you cram this formula, since it will be easier to work through your questions and it will be even faster for you during the exam. From there we'll go to the value of the put option. So the value of the put option is K less ST, almost the same, but now you have to be very careful with what is inside the bracket for the phi. You'll notice here that it's a negative sign. Here in the call option, these are positive signs. So in the put option, we have negative signs. Be very careful with that. And then, as I had mentioned earlier, the payoff of the put option is K, maximum of K less ST and a 0. So it kind of follows the same principle here as well. From there, we go on to look at the German call again formula. So this is very similar to the Black-Scholes formula. Only here we are also accounting for the dividend rate. The dividend rate in this case is given by Q. And it goes without saying that the dividend rate will be attached to the share price and not the strike price. So you see here, this is what is used to account for the dividend rate. And again, it is attached to the share price and not the strike price. Be very careful with that. Similar to the put option, it will be attached to the strike price, to the share price and not the strike price. And this is what is used to account for the dividend rate. The values of D1 and D2 are almost similar to that of the Black-Scholes option, the Black-Scholes formula, only that in this case we have a less or a minus Q in this bracket. The formula for D2 is exactly the same as a Black-Scholes formula. From there, the other part that the examiner is very fond of testing is the delta. And the delta for the European non-dividend paying option is the phi of D1, while the delta for a non-dividend paying put option is the negative phi of negative D1. In the next video, I will show you how to calculate these values very easily and to save you on time, and actually these are very easy marks to get. For the European dividend paying option, it's almost the same, but now of course we have to account for dividend, which again is accounted for using this formula here. It's just the same formula that was used in the German Kollegen formula, this part here. So it comes before, just the same as the non-dividend paying option, but now you have to account for dividend. From there, we'll go on to look at the questions. So the examiner has tested this question a few times, and in the next video, we'll be going through some of these questions. This is the Actuarial Raster channel. Subscribe as we tackle more actuarial exam questions together. See you in the next video.